Hello everyone, welcome to this session. Today we are going to discuss regarding the special types of blocks, in which we are going to discuss regarding lightweight blocks or Siporex blocks, which are used nowadays very abundantly. Then stabilized soil blocks, which are abbreviated as SSB, fly ash bricks or fly ash blocks, which are popularly known as FAB. So let's discuss regarding the lightweight blocks or Siporex blocks or or autoclaved aerated concrete blocks. So you can see the view of this. Now these blocks are very lightweight and can be very handy and placed very easily in the construction. Autoclaved aerated concrete Siporex block is made of Portland cement, fine aggregate, fly ash or sand, water and an expansion agent. The autoclaving process results in the production of air voids in the material, making it less dense, easy to cut or mold, and better insulating. Autoclave is a strong pressurized steam heated vessel. What are the advantages of these Siporex blocks? Now, one thing is the reduced dead loads. Using Siporex blocks reduces the load on the foundation and other structural components in a structure due to its lower self weight. About 55% reduction in the weight of walls can be obtained when compared to that of wall made with the clay bricks. Environmental impact. Siporex blocks uses fly ash 70% of its weight, thus provides the most constructive solution to the nation's fly ash utilization problem. Fly ash is an industrial waste product, and use of fly ash in the Siporex block production process takes care of these issues concerned with its disposal. Excellent acoustics. Autoclaved aerated concrete has excellent acoustic performance and can be used as an effective sound barrier. For example, Siporex wall panel. The small air pockets that are generated during Siporex production prevents the sound from traveling from one side of a wall to other side. So having the excellent acoustics. Fire resistance. An important reason for Siporex good fire resistance is its relatively homogeneous structure. Unlike the normal concrete where the presence of coarse aggregate leads to differential rates of expansion, cracking, and disintegration. Ventilation. Autoclaved aerated concrete is a very airy, thus allowing more diffusion of water, reducing humidity of a building. So also it helps to maintain the proper ventilation inside that particular unit. Energy saving. The remarkably good insulation properties of autoclaved aerated concrete mean a pleasant interior environment is achieved. In most cases, the need for supplementary insulation can be avoided. It has very low specific conductivity. This makes heating or cooling air conditioning very efficient. Accuracy. The accurate manufacturing process ensures that autoclaved aerated concrete panels and blocks are always produced to a size as they leave the factory. This results in less on-site trimming and reduced quantities of mortar and finishing materials used. Rapid on-site assembly. The low weight of Siporex block helps in the easy loading and unloading of these items when transportation to work sites are required. Besides, it also helps the mason as he can easily lift and place the blocks. It has long life. Siporex does not deteriorate over time and they retain good finishes even after many years. They have better resistance against alternate cycles of heating and cooling. Composition: fly ash is 59%, cement usually OPC 53 grade percent, that 50 grade 33%, lime 8%, and aluminum powder 0.07%. Physical properties: density. It ranges between 300 to 1800 kgs per meter cube according to the source. Siporex is a unique industrial product that covers such a range in apparent density. Siporex products with density up to 350 kgs per meter cube can be used as load bearing construction material. Siporex with lower density are generally used for thermal insulation purposes. Porosity: classified as a capillary pore, gel pores, macropores due to deliberately entrained air, and micropores due to inadequate compaction. Fly ash is used as for more uniform distribution of air voids by providing uniform coating on each bubble and thereby prevents merging of bubbles. It is observed that the strength, permeability, diffusivity, shrinkage, and creep properties of Siporex blocks are considerably related to its porosity and pore size distribution. Permeability: permeability of the aerated concrete is greatly influenced by the type, size, and distribution of the pores and not the pore volume. Pores are generally classified into two types: open pores and closed pores. Permeability of aerated concrete is contributed by the open pores and not the closed pores. Compositional properties: scanning electron microscopy (SEM) showed that the capillaries in the Siporex are plate-shaped crystals of 11.3 angstrom tobermorite with a double-chain silicate structure. The growth rate and the degree of orientation of this structure cause differential pore distribution. Tobermorite is a calcium silicate hydrated material. Mechanical properties: compressive strength. It can carry load up to 8 megapascal, approximately 50% of the compressive strength of a regular concrete, influenced by factors such as density, age, curing method, component, and the mix proportion. The rate of strength development is initially very high and it gets decreased with age. Thermal conductivity. Thermal conductivity increases as the moisture content of Siporex increases, also increases with the increasing density. The amount of pores and their distribution are also critical for thermal insulation. Finer the pores, better the insulation. Durability. Carbonation is the one of the main factors of aging deterioration of Siporex. In cold countries, frost deteriorations are observed in outer walls made from Siporex. Surface scaling caused by freezing and thawing. The other is wide cracks formed due to inner part Siporex temperature being reduced to 0 degrees Celsius. Now let's discuss the next special type of brick, which is a stabilized soil bricks or stabilized soil blocks, SSB. Stabilized soil blocks, SSBs, are building blocks made from ordinary soil mixed with a small amount of cement and water. They are highly compacted in a block press, resulting in a low cost solid and building block. Soil has universally been used as a major building material in form of mud, adobe, rammed earth and burnt bricks for centuries. However, when used in the other form other than burnt bricks, such buildings are short-lived as they easily erode when they come in contact with water. While burnt bricks are strong and water resistant, they consume a lot of firewood. In some areas, as many as 20 trees are required to burn the bricks required to build one classroom. Burning of bricks for permanent buildings construction is not a viable option as in the long run causes deforestation. The other option of improving the soil qualities to make it suitable for building permanent building is a stabilization with cement as a building agent. When small amount of cement 5 to 10% is added in to the soil and then compressed mechanically to make building blocks, the resultant blocks are water resistant and their compressive strength highly increased, making it strong enough to build build buildings up to 3 stories high without using columns when using normal blocks that are cemented together with the mortar. The introduction of the interlocking stabilized soil blocks ISSB is gradually revolutionizing the building industry as the ISSB technology reduces construction cost as cement mortar is not required to lay the blocks and construction time and labor is significantly reduced. Now you can see here the house constructed with the stabilized soil bricks. Now even you can see the elevation of this particular house or the aesthetic. It is similar to the other high cost blocks. So as we have discussed earlier, you can see this particular manufacturing process at a small level where the earth is added to the block and cement is some percentage to added it to that and it is pressed in this particular block. Next we will discuss regarding the next special type of brick as a fly ash brick especially or fly ash blocks which popularly are called as a FAB. So fly ash brick is a building material specifically masonry units containing class C or class F fly ash and water compressed at 28 megapascal to 78 atm and cured for 24 hours at a 66 degrees Celsius steam bath and then toughened with an air entrained agent. The bricks last for more than 100 freeze thaw cycle owing to the high concentration of calcium oxide in the class C fly ash. The brick is described as self cementing. The manufacturing method saves energy, reduces mercury pollution and costs 20% less than traditionally clay bricks manufacturing. So you can see here view of a fly ash blocks. Coal dust has historically been collected as a waste product from home and industry. During the 19th century, coal ash was taken by scavengers and delivered to the local brickworks, where the ash would be mixed with the clay. The income from the sale of ash would normally pay for collection of waste. The clay is typically entrapped during the formation of coal. When coal is burned, the incombustible clay proper particles are left behind and ash. In great boilers, incombustible ash agglomerates as cinders through prolonged residential time. Nowadays, pulverized coal technology is preferred due to its improved energy efficiency. In this case, the ground clay escapes along with the flue gases, settles as a ash in a bag filters or electrostatic precipitators (ESPs). This gives rise to the fly ash. Now, the raw materials that, as we have discussed earlier, as the fly ash generally used as a 60%, sand and stone dust 30%, ordinary Portland cement, which incorporates lime and gypsum 10%, and total formulation it is 100%. The strength of fly ash brick manufactured with above composition is ranges between 7.5 megapascal to 10 megapascal. Fly ash bricks are lighter and stronger than clay bricks. Main ingredients include fly ash, water, quicklime or lime sludge, cement, aluminum powder, and gypsum. Autoclaving increases the hardness of the block by promoting the quick curing of the cement. Gypsum acts as a long-term strength gainer. The chemical reaction due to aluminum paste provides its distinct porous structure, lightness, and the insulating properties. The aforementioned properties set it apart from other lightweight concrete materials. The finished product is light block, less than 40% the weight of conventional bricks, while providing the similar strength. The specific gravity stays around 0.6 to 0.65. Using these blocks in building reduces the dead load, allowing one to save 30 to 35% of structural steel and concrete. What are the advantages of this type of bricks? It reduces dead load on structure due to lightweight 2.6 kg, dimension 230 by 110 by 70 mm generally. Same number of bricks will cover more area than the clay bricks. High fire protection, fire insulation. Due to high strength, practically no breakage during the transport and use. Due to uniform size of bricks, mortar required for joints and plaster reduces almost by 50%. Due to lower water penetration, seepage of water through bricks is considerably reduced. Gypsum plaster can directly applied on these bricks without backing coat of lime plaster. These bricks do not require soaking in water for 24 hours. Sprinkling of water before use is enough. Some disadvantages also are observed in this brick. Mechanical strength is low, but it can be rectified by adding marble waste or mortar between blocks. Limitation of size. Only modular size can be produced. Large size will have more breakages. It is only good for the places like a subtropical area or area where the climate is warm because it does not absorb heat. But during cold, it is not useful. So today we have discussed regarding this special types of bricks where the advantage of the local material or locally available material can be taken and required the strength can be obtained. So thank you very much for joining this session.